All right, good afternoon or morning, Intro to Engineering. This is a additional video for Activity 4.5 Cams in Motion. There are two PowerPoints within that. The first is Basic Assembly Constraints. The second is Creating Drawings in CAD. So we're going to go over both of those. Before we get into Assembly Constraints, I'm going to do Creating Drawings. No, let's do Assembly Constraints first. So I'm going to go ahead and pull this up. So for our basic assembly constraints, we're going to talk about the different constraints that you can use to put different parts together. All right. So the first thing is that every item we create has 6 degrees of freedom, 6 degrees. All right. 3 of those are rotational. And if you look down here at this little axis, each of these arrows, you have one in the X direction, one in the Y, and one in the Z. And then if you look at each of those, okay, there is a circular arrow, an arrow that wraps around the axis for the X, Y, and Z. So you have 3 rotationals, okay, those are about the X, Y, and Z, and there are 3 translationals among the X, Y, and Z. So there are 6 directions that you can possibly move when creating different parts or assembling parts, and this is important to know. It will come up again, I promise you. All right, there are 6 degrees of freedom, and you need to be able to explain what that is. So degrees of freedom are systematically removed in an assembly until each component is constrained to allow the desired behavior. So everything can move around until you constrain it to not move, right? There we're constraining or restraining it so that it only does what we want it to. So we have 4 different types of constraints. We have a mate/flush constraint. Excuse me. We have an angle constraint. We have a tangent constraint, and we have an insert constraint. Okay, and I'm probably just going to point with my hand. I think it's a little easier to see. Okay, so mate, okay, angle, tangent, and insert. And then we have a 5th one, but we're not really going to get into that, all right? So those are the 4 main ones. They break down a little further. So a mate constraint will take 2 edges and constrain them together. So, for example, if I want to constrain this surface to the surface of this, I would use a mate constraint, and I constrain these 2 surfaces together, and it would lock them together like this. All right, that doesn't mean that it can't go up and it can't go down, it can't go left, it can't go right. It just means those planes are surfaced together, okay? So that would be mating a constraint, and that would be your mate. Now you also have flush constraints. A flush constraint is if we have this surface and this surface, and we want them to be flush to each other, okay? So then it would constrain so those are flush to each other, all right? Instead of like this, they're flush with each other, all right? Angle constraints. So you can constrain it so that they're 0 degrees, like so, or constrain them different so there are different angles. If you want these 2 surfaces to have 90 degrees between each other, you could constrain them so that they're 90 degrees to each other. So the angle constraint allows us to do a little bit more than what our mate and flush constraints would allow us. A tangent constraint is exactly what it sounds like, is where you constrain a curved surface to a plane of another curved surface. So maybe you got the curved surface of this here, and I want to be constrained to that plane. They are now tangent. Okay. Insert constraint. You could also use a mate constraint if you would like, but insert allows you to, for example, put the peg into the hole. So if you had a screw that you wanted to insert into the hole, then you would use an insert constraint. So your base components, the first component is placed in assembly, should be the fundamental part of the subassembly. What this means is a frame, a base plate. In this example of 4.5, you guys are going to be working on the Cams in Motion project, so the box would be the fundamental part. The fundamental part of the subassembly, and then everything else sets into that. So you would ground the box so it doesn't move around. All right. When the first component is placed in the assembly, its origin is coincident and aligned with the assembly coordinate origin, meaning when you have an assembly, it's going to be X, Y, and Z. That first item you put in is going to be in line with that. Everything else then kind of goes around it. The base component should be grounded to remove all the degrees of freedom. So to make sure that you cannot rotate, you cannot move the box, you guys would ground it. And we're going to go over that. But so, for example, we have a cell phone case back. Okay. You can double click on a component to exit the assembly environment and enter part environment. And we talked about that in our last videos when you guys were putting the planes of existence like XY and ZY or YZ planes on the hexagon cam part. It'll make everything else become translucent while we do that. And then when you're done, it'll bring the part saved into the assembly file. Okay, so that's a pretty quick version of this. The best way to get to learning this is just playing around with it. Now, the thing you have to keep in mind is that when you do a constraint, okay, so once you constrain something together, if you have another constraint that conflicts, then it won't let you do it, and you'll get some warning messages, and you may not think there are constraints that are interfering, but just go back and check and make sure that there's nothing else in the way, or there's a constraint that you accidentally constrain to an edge instead of a face, because you can constrain to the face of a surface, one of the edges, all right? So there's different things there, just to make sure you're looking into. So our second PowerPoint here, I'll go ahead and log out of this. Creating drawings in CAD. This is a pretty straightforward PowerPoint here, but to create your drawing, so once you've finished a part file and you've done your assembly, or if there is no assembly and you're just creating a single part, okay, we're going to create a drawing. So the part file is here. This is a very basic thing. It's literally a bunch of 1-inch cubes put together, or they may not be 1-inch, but they're all equal cubes put together to create this shape. And that's your part file. And then you'll save your part file. And to create a new drawing file, you're going to do an IDW, not a DWG. All right, there are two different types of drawing files. All right, in this class, we're going to use the IDW file. So you'll create a new IDW. And then the first thing you need to do is change the sheet size to A. All right, the reason why it comes in as a very large piece of paper, we can only print an 8.5 by 11 sheet of paper, a normal piece of paper. Okay, to do that, it's pretty simple. Over here in your browser window, and this will look exactly the same. Underneath the Drawing Resources tab, all right, there is the word Sheet 1. You'll right-click on Sheet 1, and then you'll go down to Edit Sheet, and you'll get this window here. Over here, there's a size box. You're going to change that size to A, and then click OK. And that will change the sheet size down to an 8.5 by 11 instead of a large piece of paper. Once you're done with that, you will need to change the title block, and we're going to get into that in just a second. So you'll select size A. So now you have to change the title block. So underneath Sheet 1 again, you're going to right-click on ANSI Large, and ANSI stands for the American National Standards Institute. So it's a standardized block that engineers use in working drawings. You're going to delete that box though. All right. The ANSI Large title block is for sheets of paper that are much larger than what we're using. So once you're done deleting it, we're going to bring in a new one. So we're going to add what's called the size A title block. And to do that, underneath Drawing Resources, so you'll have Drawing 1, Drawing Resources, and then you'll open Drawing Resources. It's just like a normal folder system in Microsoft or anything like that. You're open Drawing Resources, and you're going to go down to Title Blocks, and you're going to open Title Blocks, and you'll see two options. One is the one that you just deleted, and one is ANSIA. You can right-click and do Insert, or you can just double-click on ANSIA, and it's going to put that into the paper. All right, after it's in your drawing file, you're going to edit the title block. So to do that, in the top left-hand corner, you'll have a symbol that looks like this in Inventor. You click on that and you go down to iProperties. And from iProperties, you're going to get this window here. And you'll have a tab up here, General, Summary, Project Status, etc. Okay, you're going to go to Summary. And these are the blocks you're going to update. The title, subject, which would be Intro to Engineering. Your author would be you, your name. Okay, the manager would be Mr. Richmond. Company would be Belmont High School. All right, and then you're going to apply that. Okay. All right. Once you've done that, and you come back here, the title block will be updated with some of that information that you did. Okay. The next thing we're going to do is we're going to bring in the actual part file so that it is now on our drawing. And to do that, you click on Base. Up here in the top left, there's the word Base. You're going to click on that, and this window is going to pop up, Drawing View. From there, there's a drop-down menu, and that drop-down menu is right here. Okay. You'll click on that, and you'll select the file that you want, whatever you named it. So this is why good file management is important. You need to know where you saved your files, number one, and you need to know what you saved them as. All right. If you have extra files that you started but are wrong, make sure you delete them. Keep things clean and organized. All right. So you click on the drop-down menu, select the item, and you'll end up with this here. Before you click OK, there is this view block that pops up. We're going to go into that. You're going to scale the drawing down. Okay, you want the drawing to fit a front, top, side, and isometric view all in one paper. So if it's too big, you will need to turn the scale down, so like 1/2 to 1 or something like that. Next will be your view block here, the view cube. These little arrows here around the view cube, if you click those, it'll rotate the object. Remember, it is just because it says front view doesn't mean it's a good front view. It is your responsibility to select what would be the best front view in this case. So the front view is going to be whatever you choose it to be. All right, and once again, front view should be the one with the longest dimension, shows the most contour, the least amount of hidden lines. All right, so once you do that, okay, you're going to click OK, and it'll be this image by itself. Next, you're going to click Projected, and then you're going to go back and you're going to click on the base view. Once you click here, you just go up, click, come back down, go to the side, click, go up and to the right, click, and you'll have 4 boxes. And then you'll do right click on the last view and select Create. And this will put in all 4 of your drawings. So we have a front, top, side, ISO. Okay. The next thing is you need to make sure that your isometric drawing is shaded like so. To do that, double click on the isometric drawing, and then you'll have this window pop up again. Over here, there's a button, and that's your raster shading button. Okay, you're going to click on that, and then you'll click OK. So shaded, isometric, we always recommend scaling it down about half of whatever your normal drawing is. It's not a necessary dimension drawing, so make it large enough to be able to see what's going on, but not enough that you have to dimension it, okay? Just, you want to make sure you leave the space needed for your actual drawing files. So you're going to shade that. So now we have this. Next, you're going to do your dimensioning. And to do that, in your main window, you have Place Views, which is the tab you were under. And now we're under Annotate. So you're going to click on Annotate, and you'll get this whole toolbar. You're going to click on Dimension. And then to dimension, you're really just going to click on the objects that you want to dimension. So if I want to know how far it is from the left side to the right side, you see the 2 blue lines. I would click on this line, and then drag down and click. And it tells me it's 3 inches. Then I could do it the same for here. Side to side, drag down, 1 inch. And you don't have to hold, you just click, click, drag down, click. Okay, Same thing for there. This would be like click, click, over to the side, click. And then click, click, over to the side, click. All right. So you can do that to make sure that it's dimensioned right. Once again, you want to make sure that you don't over dimension, okay? But you don't want to under dimension, that's the main thing. So here's an example drawing. This is 1 inch tall from here to here, 2 inches complete, 1, 3, 2, and 1. All right, and that is a fully dimensioned drawing for that. Very simple object. Okay, so that is how to create a drawing file. What I would recommend is before you get into too much, try doing just that. Create this. The dimensions are here. You can create this part file based off that information, and then make your own drawing file, and it should end up looking exactly like this once done. So that's your creating a drawing. I'm gonna go ahead and minimize that, and that will finish out the videos for 4.5 Cams in Motion. All right. Anything from those PowerPoints, anything that we went over in the videos, that is able to be on a test. And a lot of it will be on a test. So make sure you talk to your other students in the class. Make sure you talk to the sub if you have any questions, want anything clarified. Any of these vocab words might be something, nudge, nudge, wink, wink, that you may want to know. All right. But we're going to go over that at a later date. Make sure you're ready for the test. The next unit is going to be 5.1, properties and shapes, and so we'll get on to that with the next video. 4.6 we're going to come back to later. All right, that's not going to be towards the end of, that's going to be towards the end of the school year, because you're going to design a camper, your automata project. So with if you have any questions, email me. If I can answer them, I will. If I can't, I apologize. I just don't have access to email them. But make sure you study for that test, and good luck. Have a good day.